Okay, and here we go, having a look at another length of a curve effectively. In this case we're dealing with this function here, which obviously has roots at 0 and 2. If y is 0, x being 0 will do it, or if x being 2. So you get these 2 points, and we get a loop. And we're trying to find out what the perimeter of the loop is, trying to find the length of the curve here and here. Okay, so the same thing we're going to do as previously. We're going to use our formula for finding the length of a curve, which is here, and it's based on dy by dx. So the first thing we're going to do is be able to get dy by dx out of this, and we have a couple of choices. We could do it parametrically, or we could do it by rearranging, and I'm going to go for rearranging here because I want the answer in terms of x, so I can integrate it dx. So if I just rearrange this thing, I get y equals 1 over root 6, root x 2 minus x is the rearrangement of that equation, and if I differentiate that, it's going to be 1 over root 6, obviously at the front of a product rule. And if I muck around with that, and you can do it yourself, save a little bit of video time here, you end up with 2 minus 3x over 2 root x as an expression of that. So you have to do a product rule, so going from there to there. There's a product rule involved and a little bit of rearrangement, so you can have a go at working that out. And in the expression for the curve, I need the first derivative squared. So that's going to be, this thing squared is going to be 1/6 of 2 minus 3x squared over 4x. Okay, so that's what I'm going to need to be playing with, which I could write as, if I expand that bracket out, I would get 9x squared minus 12x plus 4 over 24x. Okay, so that's a expression that I can deal with, that I've got for my second derivative, my first derivative squared. Okay, now the expression for the curve is from the limits of integration, square root of 1 plus the first derivative squared, dx. Okay, notice that this is a positive square root, so I'm going to get the top half, so when I finish it, I'm going to have to double it to get the length of the loop. Okay, so let's have a crack at tackling this thing. First thing is to put a common denominator, so it's going to be 24x over 24x. So if I put an extra 24 in here, this one will turn to a plus, so I get 9x squared plus 12x plus 4 over 24x dx. And that top line looks to me to be suspiciously like a complete square of 3x plus 2 squared over 24x, square root of all of that. Moving down the page a bit, which means that that square and the square root will disappear, so I've got the integral from 0 to 2 on the top, 3x plus 2, and on the bottom, square root of 24x. Okay, and that's integrable if you split up into 2 bits. So that's just going to be integral from 0 to 2. Let's take that 3 and root 24 out the front. And then I've got x over root x, which is just root x, plus the second bit, the 2 and the root 24 out the front. And then I'm left with just 1 over root x. Okay, so I just split into 2 separate bits, which I can integrate separately. So I'm left with 3 over root 24, and if I integrate root x, which is x to the power of a half, I get x to the power of 3 over 2, 2/3, and I've got 2 over root 24 here, and that's x to the power of negative a half, so if I up the power when I get a half, 1 over a half is 2. Okay, and then it's just a matter of sticking the limits in and evaluating the whole lot, and it comes out to be 4 over root 3. Okay, which is, as I said, the length of the positive square root. I've only done the positive square root here, so it's the length of the positive square root is the top half of it, so the loop will be twice that. So the length of the loop is twice that, or 8 over root 3. Okay, so that's how you go about doing that, with a couple of bits for you to fill in. So you need to do the product rule up here to work out what's going on with the first derivative, and there's definitely some calculated work in here. Well, I wouldn't do it with a calculator, I'd do it by surds, so you can choose. If you want a calculator, you won't get 4 over root 3, you'll get a decimal, which I think is about 2.3 if I remember rightly. But that's basically how you go about doing it. So this technique enables us to work out lengths of curves.